And our next speaker is from Nota AI, and his name is Jongwon Baek. He's gonna talk about PyNetsPresso and LaunchX, an integrated toolchain for hardware-aware AI model optimization and benchmarking. Jongwon Baek is a product owner of NetsPresso at Nota. He holds a bachelor's degree in bio and brain engineering from KAIST and a master's degree in culture technology from KAIST. Before he joined Nota, he had worked as a data scientist, a data engineer, and a software engineer in several companies such as Krafton and Nexon. At Nota, he led the development of NetsPresso, the hardware-aware AI model optimization platform, for the last several years. Yep, so seems like he's ready. Please welcome him with the applause.
Oh, thank you very much. Today, I want to introduce to our product. One is PyNetsPresso and LaunchX, which are the easiest tool for edge AI engineer. Today I want to talk about problems that many of you face every day. This slide shows how we develop AI applications and the and the scope of edge AI engineering is starts from modeling and ends to deploying. So journey of edge AI engineer starts at model and ends at device. But during this process, it would be great if there were no issues, but in reality, that should not erase the easy process. Unlike our plans, we often encounter challenges before completing the journey of edge AI model to the device. What if an edge AI engineer should deploy on the 3 target device on one model? Then there are so many things happen in the process. At the first, you should learn about the various types of SDK. Each target hardware have their own SDK usually, so you should at least 3 SDKs in this case. And each SDKs have diverse model conversion options and quantization options and other so many options there. So you should learn about that. And even the conversion is done, that doesn't mean all the difficulties are over. Since each hardware has their own limited operations, in result errors if your model has unsupported operations on the device. And in some cases, the AI model size is larger than the hardware's memory size. Then you encounter the out of memory error. Even if the AI model works on hardware, it might be slower than you expected. Every AI application have their own limitation. So latency is one of them. So you need to compress the model to meet the latency. When the model doesn't work properly on the hardware, the edge AI engineer has to go back. In many cases, they might even go back to modeling stage, which is very early stage of the process. So it is quite hard process. Or you can choose better approach. The better approach is NetsPresso. This is our solution, NetsPresso. NetsPresso is a tool that helps solve the mentioned problems. It unifies the interface of different SDKs for various devices and it assists in choosing the optimal settings for converting the model. It can also replace operators without affecting the model's result. Furthermore, NetsPresso makes it easy to compress the AI model to solve memory or latency issues. NetsPresso consists of 3 parts: model searcher, model compressor, and model launcher. Each step is responsible for generating model, model searcher, compressing model, model compressor, converting and benchmarking model launcher. Model searcher provides features to design and train AI models. It offers image classification model, object detection model, and semantic segmentation models. We have so many good engineers that specialized on design model architecture, so they made very good model architecture tailored for your target hardware. And we provide customization service to add more models you specifically want. And next, model compressor. Model compressor compresses the user's model with pruning and filter decomposition technique. It can compress various CNN-based vision AI models, but after recent updates, transformer-based vision AI models can be compressed as well. It automatically finds the optimal compression parameters to minimize performance degradation while obtaining the most compressed model. Or users can also set detailed options for compression. Even you can choose the layer, and you can choose the channel index, and the model compressor will prune the exact channel you select. Model launcher has 2 functions. One is model converting, the other one is benchmarking. In model converting stage, we unified various type of SDKs in one interface, so you don't need to learn so many about so many SDKs. And in case of benchmark, we have device farm, which is it is set of real hardwares, so you can benchmark your model really actual hardware, and can it can measure memory footprint or latencies on the actual hardware with the benchmark function of model launcher. So many problems I mentioned before can solved by these 3 modules. You can choose the module that will be used for solving problem, depending on what caused the problem and what the simplest solution. You can choose a proper solution in these modules. And NetsPresso goes beyond technical benefits. It automates the development process of AGI models so that make work more efficient. Especially PyNetsPresso, which is Python library interface of NetsPresso, is ideal for automating the entire process of developing and lightweighting AI model. Nota AI provides many AGI models that optimized by NetsPresso. We've adopted a detection model that previously didn't work on Renesas RA6 M3 device. And in Sony case, our target hardware was IMX 500, and we achieved higher model performance while maintaining the same latency as before. And this is ST Microelectronics case. This is our most recent collaboration. ST Microelectronics has their own model zoo and provides the STM32 Cube AI, which is a little bit similar to model launcher. Through this collaboration, we compressed models from STM's model zoo using NetsPresso's model compressor and deploy it with STM32 Cube AI. The source code for the whole process will be shared by Nota AI and ST Microelectronics later. This is very good example for streamlining edge AI development with PyNetsPresso. It means you can integrate this NetsPresso into your pipeline with the Python library interface. This is the result of this collaboration. We achieved a performance improvement in a MobileNet V2 based image classification model. Accuracy remained almost unchanged here. Then RAM activation decreased by 14%, and flash weight decreased by 61%, and inference time became 24% faster. This result was achieved using only default options, any detailed setting of the pruning options. In this compression process can be implemented by just a few lines of code. You can see the code at the Nota booth next room. We are developing a service that can optimize models from various sources and deploy on different devices. With integration to model device ecosystem, Nota can play a role as a bridge connecting models and devices by the Nota AI's optimization technology. We have a close collaboration with ST Microelectronics and NVIDIA Tau, and now we are collaborating. And you can learn more about it at Nota AI's booth. In this context, we'd like to introduce two useful AI optimization tools. One is PyNetsPresso, which allows you use NetsPresso's features in Python library form, and the other is LaunchX, a tool that simplifies model conversion and benchmarking. This is PyNetsPresso code. This code is from the collaboration with ST Microelectronics, so you can see here. At the first, to use PyNetsPresso, you should learn the login code with NetsPresso ID and password. This is the uploading part. You can upload your model with your model information, like dimensions, channels, and batch. This is compression part. You can specify the what you want to use, the compression method and the pruning ratio. In this case, you can specify the recommended ratio 0.5. Then that means globally in the whole model globally prune 50% of channels will be pruned, but the detailed options will specified by NetsPresso automatically. Following this compression, it is essential to retrain the compressed model and deploy it using STM32Cube AI. We will soon release the complete pipeline code. Now let's move on to LaunchX. The first screen shows two features, one for converting model and the other for benchmarking the converted model on the actual device. It is very simple and intuitive tool. At first, you should upload your model. In this case, I uploaded lightweight YOLO Nano ONNX file. Then I choose the target framework as TensorFlow Lite, and I choose Ensemble E7 DevKit Gen 2, and output precision is into 8. Then you can choose the device, and then you can click the convert button, and in about 5 minutes you can download the converted models. For benchmarking, you should upload model also. In this case, we have model test.tflight, which is converted to tflight from ONNX. And you can select the device. You can see only comparable with tflight you uploaded. In this, for now, the displayed device here include Raspberry Pi and NVIDIA Jetson series only, but in fact we support more devices like Renesas and other devices. If you want to add your device on this service, it is possible to collaborate with us. Recently, 2 devices that are equipped with ARMS MCU and MPU have been added to LaunchX. You can see these devices in LaunchX next week. Anyway, you can click the benchmark here. Then this model file is sent to actual device, and on the device you can check the inference latency or memory footprint. This depends on the hardware. So LaunchX is very easy and intuitive tool. In my presentation, I have presented to you our AI model optimization platform called PyNetsPresso and LaunchX. And Nota AI, many edge AI engineers encounters the same obstacles and complexity you encounter. Using our knowledge and experience gained from these challenges, we've developed PyNetsPresso to help edge AI engineers. You can check out these products at our booth, try it out, and let us know what you think. We appreciate your feedback. Yeah, thank you.
Thank you, Jongwon.